Alright, let's see. Does it recognize it? I hit start streaming. It does, okay.
Excellent
We're live.
connection.
I have to check these
Sweet.
things because, sometimes it just, it doesn't work and you're like, oh, well, I just sat there talking to myself for 2 hours. I always hate that. Anyway. Last time we were looking at this diagram. Maybe I should blow it up a little because it's a little bit hard to see. And this was like the basic design I think we came up with, or like I came up with, based on this book I was reading.
Yes, this is looking familiar.
Yeah, I know. It's been a while, so it's been a month since I last streamed because I've been dealing with so much meetup stuff, and I'm currently organizing a game jam for the company. So,
Man, jeez, Louise. That's pretty cool, though.
yeah, I think it'll be fun. Oh
That
my
seems
god!
like a totally awesome thing to have as like a company event. Can't believe nobody thought of that sooner. That's awesome.
Well, we didn't really have enough people to really run it, I think, but or like run it and have like a lot of participants. But I think this time, since we've grown to like I think around 50 people now, it's gonna be possible.
Holy smokes!
Yeah, it's a very blustery day outside, by the way, and I don't know if that's coming through the microphone, but like you might hear like horror movie noises occasionally, just because it's so windy outside. I don't know if it's like that where you are right now, but it's pretty.
Yeah,
scary.
it's pretty windy.
Yikes. Okay, so let's dive right into this. So last time we were starting with the Haskell implementation. I think after the Haskell one, we're probably gonna hit the Java one. That should be fun. But we were just doing some comparisons, and I talked a little bit about how you do like IOC in Haskell. And last time we ran into a bunch of issues where the code didn't compile, and I just kind of gave up. So this is the code that we had last stream. This the commented out code. So the way you do multi-line comments in Haskell is you do this curly brace, and then you do like a dash, and then if you end it, you
just
do
never
this.
got like, why are there so many different ways to make a comment?
I know
like, Can we just stick with the //
I know. It bothers me so much. It's just like HTML comments; they're completely different, and like Haskell's comments are different, and God. Yeah, I miss the slashes, and unfortunately Idris also does this thing because it's based on Haskell's syntax. Like it's mostly the same as Haskell. It's because it's trying to be familiar to Haskell developers, but yeah, I miss the slashes and like the more C-like syntax. It just drives me crazy. I never have to like memorize another syntax for like comments and stuff because it's like
yes.
Because then I forget, and I'm like, how do you do a multi-line comment again? And I have to go and Google it, and then it's like,
Yeah, totally.
So yeah, this is our code from last time. It didn't work, and the part of the reason is because this one didn't have the extra return part. So we were supposed to have some kind of like return like this for our continuation. So the way that this works, just as a refresher, is we're defining DSLs, or these like languages, and the instructions are defined as the constructors of the language data type. Everything that comes before the last two arguments here, or I guess, well, I shouldn't say arguments. The last thing here is the return type. Anything that comes after the last arrow is always the return type. This is a continuation, so we have to take that as an argument. So that's always going to be like the, I guess, last argument in our argument list for all these things. And
it's a little bit hard to parse the signature. Like I understand that after the last arrow, that's the return type.
Yeah.
But then, like, I feel like, are we missing some parentheses to make it clear what exactly we're passing in here? Like, what are we passing in here? So we have B, like, is B to A, this is a function, and then that return. Could you just like run through that part of it again?
Let me write this in, I don't know, C# syntax?
Okay.
So in C# syntax, it might look something more like this. They use angle brackets, right, for generics?
I think so.
Okay, yeah. So this is like a generic. The function is called foo in this case. Foo is actually a constructor for the lang f data type, but the way that constructors work in OO is a little bit different from the way they work in FP. And it takes an argument type B. We don't know the name of this argument. It's just going to be something like that. Oh yeah, we're going to have to do something like this. This is a little bit annoying, actually. And yeah, I think that works. I think that's the syntax for for C#. It's something like this. So we're taking 3 arguments. The last one is a func from A to next. Something like that.
Okay.
So that's the equivalent of what's going on here.
Right. Okay. So we have taken 3 arguments and we return a lang f.
Yes, and what's interesting about this is that you can actually pattern match on the constructors. So if I have a function foo that takes a lang f, or yeah, you know, let's say it takes a lang f as an argument and then returns like, I don't know, IO unit. Then we can take our lang as an argument here, and we don't care about the right hand side. One thing we can actually do is we can pattern match on that. So we can say we have a foo and it has a B, an A, and some kind of continuation. And if we had another instruction in here, we could do, I don't know, like bar. And this one has like fewer arguments. Then foo could take this instead. And yeah, we could basically match on each of the different constructors for this data type. So it's kind of like an enum in a way. So lang f could either be a foo, which has these 3 arguments, or it could be a bar, which has these 2 arguments. So that's
is that like overloading in OO? Like if you have a lang f and you can have a function lang f and it can have a different signature.
Not really. It's more like lang f is a data type like this, where you have foo, B, A, and this A to next thing. Or it's a bar, A to next. So something like this is the equivalent, I would say.
Okay, so it's like a super enum.
Yeah, it's like a super enum, where you can like pattern match on the different variants, and then so like if it's a foo, then you do this stuff, and you can extract the arguments that you passed into the constructor. So that's generally how this works. It's a nice feature. It's something that Rust also has. They're called algebraic data types usually, but yeah, that's equivalent. This syntax that we use down here looks different from the one I just showed you, but both of them work. It's just that for some cases this is a preferable syntax. It's a little bit more powerful. It's a little bit more flexible. It's also a little bit wordier in some ways, and a little bit more confusing because of this last little bit here. But
just like to make this a little bit more concrete in terms of I've like what did you say, it was algebraic data type or something in Rust, but I can't remember the terminology of this super enum. But basically, like, could you give me an example, just like a simple example? Like, here's where this would be useful. Maybe it's
okay, sure.
Think of that off the top of your head. I don't know, but just to make things more concrete.
Yeah, there's usually a lot of good examples. Let me think. One that I know of that a lot of people like to use is like result. So result can be something like okay, and you take some type there, or you could have an error and you take another type there. And what you can do is you can take, I don't know, handle error, and it takes a result. Oh, it probably needs it needs an A and a B on the left side. And so let's say that our error type is, I don't know. Wow, I somehow managed to turn on sticky keys.
Sticky keys, the bane of my existence. I still don't know what they are, but I periodically have to close that window.
No, please. I don't want that. ignore that.
Oh wow, this is a game changer. I
Ignore
didn't
that.
even know you could turn that off.
All right, there we go. Hopefully that fixes our problem. Sorry, I got interrupted by sticky keys. Cool. Um, so the left argument is going to be our return type if we don't have an error, and the right hand side is going to be our error. So we'll just call that. We'll just make it a string, right? And so yeah, we'll take one of those. Maybe we'll do like an IO unit here. So this is like a very basic example, but if you take the result here, you don't really know what to do with it until you actually pattern match on it. So in this case, we'll just check if it's an error, and we know that our error is a string. So now we can do something like put string line E. In the other case, if it's okay, we know that our result is actually an integer. So we can actually take A and we can add like 2 to it, and then we can print that out if we want to, like so.
Reminds me vaguely of optionals, where you can have just like you pass it an optional of something, and then you need to check if there's something in the optional.
Yeah.
And then if there is, you do this. Otherwise, you do that.
Exactly. Yeah. It's just like an optional. An optional is kind of an example of this sort of thing. It's just that this in particular is this one's for error handling with more information, I guess, because in optional, if you get a none or you get like the equivalent of a null, that doesn't carry any information in it. But in this case, the error carries a string, so we can actually print that out. And like that's cool and all. You can kind of do that stuff in Java as well. The real superpower here is when you start doing this stuff in Haskell, because once you have different functions that return results, you can actually compose them more easily. So one thing you can do is use this like do syntax, and let's say we have 2 functions that return errors. Okay, let me go through this real quick. So we'll call this one error A.
Quick terminology question. When you say compose, you mean like C# link stuff, where you're just like chaining a bunch of operations together to get you the result you want?
Yeah, you could say that. Well, I'll show you in a second what I mean. So let's say these both return. Oh god, I've messed this up for myself because in Rust I think its left side is okay, and the error is on the right hand side of the result. But in Haskell, it's the other way around. It's like this, because they're like, well, if it's right, then it's right, and if it's not right, then it's left, right? Like, but yeah, I'm. This is something that I get mixed up on so much. It's just crazy. But
it's like
in this
the
case,
old expected versus actual.
Yeah, it's like, which side is it? I don't know. I just get them mixed up all the time. In this case, I'm going left side is okay. Actually, you know what? They have something for this in Haskell. It's called either. So either is what they use. And the right-hand side is the correct result, left side is the error. So we're just going to do that. We're just going to go either, string int. Same here with error B. So error A, let's say that this one returns a right, and we'll give it 2. So here we're constructing an either that holds an integer, so it has to be it has to be a right, essentially. If it was an error, then we'd have to go left. This wouldn't type check, but this would, for example. Let me know if this is clear, because I'm getting my thoughts all like spaghettied on themselves, because this is sort of a tangent that I didn't expect to go on today.
Yeah, no, it's I'm still a little bit foggy as well. I'm conscious of not wanting to completely derail things though, because I know you gotta like stuff you want to get through. So we could just like
we'll go through this quickly, because I think it's important to know. But this is how either is defined in Haskell. They have a left constructor and they have a right constructor. So left takes the error type, which is on the left-hand side. Right takes the non-error type, which is on the right-hand side. So an either is, well, either a left that holds a value of type A, or a right that holds a value of type B. So I don't need to redefine that. That's just built in. And these are a couple of examples of how to construct an either of type string int, like this. And we could have a function foo. I really like using foo. It's just such an easy name to reach for. And this one can do, oh, I don't know, we'll just return another either string int, let's say.
So if you have like an either like this, so again, I'm thinking back to optionals, like you need to check to see if something's inside the optional before you can use it. Do you get that kind of safety with this approach as well?
Yes.
Like you have to have some sort of a check to say, okay, which side of this either am I dealing with? And then
yeah, you can certainly do that. So one way you can do that is, so let's call error A. So error A doesn't take any arguments, it just returns an either, right? And one thing we can do is this case error A of, and this will allow us to check if it's a left, then we have an error, and then we can do something with that. Otherwise, if we have a right, then that means it's some kind of result, and we can do something with that. And then we could try using error B, for example, like this. So this is something you probably have seen in like Java, right? Something similar to this. Except it might be I don't know how optionals work, but I assume it has to be something like this where you
so you could just check like, hey, is the optional present? And then it literally calls like is present or something. Or you can do a bunch of stuff, like you can be smarter about it and chain a bunch of operations together using the Java equivalent of link. To do just like, if this is here, do this, or else do this.
Yeah.
There's some like nice ergonomic stuff you can do there. But yeah, it looks similar to what we're doing here.
Yeah, so let's say that error B depends on the result of error A. So let's say it takes an int. So now when we get our result back from error A, we need to pass that in to error B. Actually, I should call these different names because otherwise it's confusing. So in this case, we can do this like big case of thing, and it's kind of ugly because you could if you have like a whole bunch of operations that you want to do in a row that all return errors, then you can imagine we get this big pyramid.
A lot of indentation.
Yeah, we get this ugly indentation, and this, you get the same sort of thing in Java as well, right? If error B relies on the result of error A, and then error C relies on the result of error B, then the indentation goes into like this giant ugly pyramid. So what Haskell has, and a lot of other functional languages have, Rust also has something that's similar to this that tries to emulate this sort of behavior. They have this do notation. So I can do error A, and then I can store the result in a variable called res, and then I can do error B, like so, and I can pass it res, and then I get res1, and then at this point, if I want to, I can just return res1. And that looks a lot cleaner. So the way that this works is if this thing fails, it'll short circuit, and it'll just do like an early return here and return the error. If it succeeds, it'll extract the value and put it into res, and then it'll call error B on res. If this fails, then it'll short circuit and it'll return the error. If it succeeds, it'll extract the result, and then it'll just return that. And this composes a lot more nicely than having to nest a bunch of case statements together.
Okay.
So this is called monadic do notation, and I kind of touched on this last time, but monadic do notation essentially allows you to just sequence a bunch of stuff, right? So this is letting us sequence a bunch of functions that return errors, but you can also do this for I/O. Like, if this were to return I/O unit instead, and let's say we wanted to print multiple things, right? Like, you know that print string line, if I give it foo, as an argument here will print foo, but how do I make it print another thing? How do I can't just put another put string line down here and give it bar as an argument, because everything is an expression in Haskell. You can't really do this. That doesn't make any sense. So if we add this do notation, then we can actually do this, because this behind the scenes will do a little bit of syntactic magic, and it'll convert this into something.
So this is like,
yeah,
when we kind of need to cheat, we have this do notation that allows us to
sequence
do
things,
right? To sequence a bunch of things. Okay.
Yeah, and it works for a lot of different things. It doesn't have to be IO. It could also be like state. If you want to do state, then you can like set like some variable, and then you could like get from that variable into a value like a, and then you could keep you could keep going with that. That's another thing that you can do. It kind of reminds you a bit of like imperative programming, and that's kind of the point.
It does remind me of imperative programming, and like the thing that comes into my mind is like parallel programming, when most of the time like you want to have multiple threads and they're all doing their things, but then sometimes, for whatever reason it's just too complex. You need that like sequential bottleneck where just like, okay, just put a lock on it and then just let me do something, and I don't have to worry about these threads tripping over each other. And then once that's done, I can go back to sort of like a more parallel approach. Except instead of parallel processing, we're going from like functional to imperative, which is kind of interesting.
Yeah, I think that's a pretty accurate analogy. So in most applications, obviously, like when you're writing like a Python script, you have to do a bunch of things in sequence, right? This is how you would do that in functional programming. You just use this do notation, and then now you're back in the world where you can like put string line here and like write to file here. So you get out all the sequencing back when you do that. So that's a recap of what we did a bit of yesterday, or not yesterday, like a month ago. So
yep, cool.
That's how we use these DSLs. We're going to be sequencing them using that do notation, and we're going to be defining the instructions as these different constructors. So the problem that we had last time was I didn't have this continuation here, so I wasn't able to actually successfully turn this into a free monad with this like
so we were missing that third argument, which was like a lambda essentially.
We needed that. So I'm gonna
what does that third argument do again? Sorry, I think you just said that, but
it's a continuation. So next is sort of like the next computation in this
right.
EDSL.
Yeah, we were talking about like the name of the proof has slipped my mind, but where it's like, okay, 0 is a natural number, and then, or it was like 1 is a natural number, and then like n plus this is the I got paged at 2 a.m. yesterday, and I didn't go to bed until like 5, so my brain is kind of wrecked.
Don't worry, it's been a month since we last touched this. I understand.
Yeah,
it's been a long time.
But it's sort of like the thing that'll take us to the next stage or instruction.
Right? Yeah. So because we're using this free monad thing, we have to do this essentially. Otherwise, it doesn't work. And it's a little bit boilerplatey. It's a little bit weird looking. Like if you look at EDSLs described in other languages like Idris, you'll find that they don't tend to do this. But that's because they're not using free, and free kind of gives us that monadic do syntax for free. So that's kind of why we like this free monad thing. It's just that we have to add a little bit of extra boilerplate to make it work. So yeah, B and A are just the arguments that we're going to be taking in. A is the return type of this instruction, and then this arrow next is just kind of boilerplate to say that
okay. It was a proof by induction. That's what I was grasping for. Okay, it just came into my mind.
Oh yeah, the induction thing. Yeah, with the
yes, that's what we were talking about.
Yeah, it was like an inductively defined data type.
Yeah, in this case, kind of like drawing some parallels for me here.
Yeah, that's the parallel that we're drawing with this particular syntax. Not necessarily with this next continuation thing though. But anyway, I think this example is really confusing and kind of bad. So I don't know. I just wanted to talk a little bit about why this thing wasn't working last time, why that was causing compilation issues. I also tried to find this like application layer interface as well, and that also wasn't working for a completely different reason. So one thing I actually forgot was this. We have to actually add yet another language extension. This one's called GADTs, and I actually don't fully understand it, but what I do know is that it's something that you can easily emulate in object-oriented programming. So this is sort of like something that functional programmers have to worry about because in object-oriented programming you kind of get this stuff for free and you don't even really think about it. But
is this another monadic do kind of thing where you just need that like oh shit button where you need to fall back on some sort of imperative style?
This doesn't have anything to do with imperative programming. This is more to do with the ability to actually define where is it? This app. So it has something to do with the generics in here, the generic type arguments that we're using here. I don't know exactly the full details of this, so yeah, we'll have to look that up another time. But all I know is that apparently you need GADTs to make this work. I didn't know, so I enabled it.
It's one of those things.
Yeah, okay. I finally enabled it today, and that seems to work. So yeah, that was what we did last time. I also tried adding like these interpret things. We'll touch on that a bit later. What I want to show you is something that I actually did successfully do. So this is new. This is all new stuff that I did here, starting from logger level or log level. Okay. Just a little breakdown is log level is self-explanatory. If you've worked with a logger before in like Java, you're probably familiar with this, right?
Yeah, the different log levels, sure.
So the log level can be info, error, debug, or none. I actually forget if there's a fourth one that isn't none. But I don't know. This is what came to my mind first.
It looks like a pretty comprehensive list to me.
Yeah, so here's our logger EDSL that matches the one in the diagram back here. So we have this logger EDSL. It's at the lowest layers of our application. And it has a single instruction, which is log message. And so if you think about what does it take to log a message? Well, you need to take the log level as an argument, and you need to take a string, that's the message that you actually want to log. And what happens when you finish logging? Well, you don't do anything, you don't return a value, so you return unit. So that's why this is unit, and then the rest of this is all boilerplate to make the the other.
Yeah, like going back to the Java analogy. I mean, I guess you probably wouldn't pass in the log level. You'd probably just set that in some initialization somewhere. But basically, yeah, you would like pass in the log level and then the message you want to log, and then you're off to the races. So if I just ignore the boilerplate stuff, that totally makes sense. It's just sort of a different syntax.
Yeah, pretty much. I guess, well, this is more like calling different logging functions, right? Because usually you might do something like logger.info, and then you'd pass in the string. But instead of having different functions, we just pass in the actual type of log we want to use.
Sure. I mean, like you could hypothetically have some log function that takes a level, and then you just have one function. I mean, people don't do it that way. I guess it's a bit nicer to have separate functions you could call, but you could just pass in a level parameter if you wanted to.
Yeah, you could do that. And so yeah, well, you could also just like wrap this function in like its own log info function and then just hard code, info as a log level, right? Like it's not really a big deal. It's not an important detail.
Yes.
But that's kind of an example of what kinds of instructions we'll be defining in our EDSLs. We're doing this deriving functor thing because we kind of have to if we want to make it a free monad. So if we want to be able to use do syntax like this, Um, we won't be able to
So
do
if we
that
want the
without
monadic
three.
do, we need this. It's basically boilerplate to enable that monadic
Yes,
do, right?
yes,
Okay.
exactly. And we could hand implement functor, and we might have to in some cases, which kind of scares me.
Oh
But
God.
but at least in this case, it seems to work if you just do a deriving functor like this. So that's cool.
Cool.
Um, yeah, down here I have the uh, logger L language that is defined as like it's the free monad that you get from passing in the logger F functor to it. So this is again boilerplate. Back up here a little bit, we have log message. This gives this is just a nice little syntactic shortcut, I guess you could say. It's a helper function. It just takes a log level string and gives you back a logger L. This will be convenient to use later on when we're actually trying to write scripts with this. And all it does is it calls this lift F thing on a log message. Oh, one thing I should mention is that this ID thing is actually built into Haskell. It's called the identity function, and as you can probably guess, ID is defined something like this. And
Sure.
it takes an argument.
When you multiply anything by 1.
Yeah, it kind of. Yeah. It's just an identity function. It takes an argument and it returns the whatever you pass in. It's nothing special. It's what we're going to use as our final continuation, I guess, at the end of this. At least that's my interpretation of how this works, because that's this third argument here, this unit to next thing. So basically, we construct a log message, we pass it to lift F. Lift F turns it into a logger L, right? Because log message is a logger F. We go from F to L, and that's it. That's pretty easy. It's pretty simple. This is also a little bit boilerplatey too. If we wanted to define other EDSLs, we'll probably do the same thing. So you'll notice that this approach already has quite a bit of boilerplate to it. Kind of annoying. That's something that I feel might be able to be made easier with like template Haskell or some kind of like macro system, but like I don't know.
Yeah, I think it just would require the language to mature a little bit more. Like I remember working on this project in university where it was basically like you could just write some UML and then it would generate all the boilerplate for you in Java, or
wow.
I think they were also working on C++.
Mm.
So kind of cool. Like it'll just give you all your getters and setters. It'll like set the visibility for you, create all your member variables. So
Yeah,
down the road, if you have more
cool.
people using this sort of thing, I'm sure some enterprising person could build like a sort of like another layer on top of this.
Yeah, maybe. I'm not really sure why it's been taking so long to get this going, but
How long
why
has
it
Haskell been
doesn't
around
exist
for?
yet.
I really don't like. I really know very. I know it's like it's one of the larger FP languages, right?
Yeah, it's one of the. Yeah, I'd say it is the biggest FP language. It's been around since as about as long as C++ has, if I remember correctly. They came out around
Okay.
the same time.
Wow.
Yeah, it's fairly old, but it didn't really start gaining more traction in terms of like actual development until later when they figured out how to do all this stuff with like monads and monad transformers, and it wasn't really well documented earlier either. Tooling was pretty bad, and even now it has some issues from it's built up some legacy cruft. So yeah, the language is I'd say it has some rough spots, and I wouldn't say it's like the best functional language out there, but it's probably the best there is right now that we have today for building software at least.
Yeah. Well, I mean, having a community is super important, right? Like, even if
Yeah,
you have some issues that are tough, just being able to ask questions, having knowledgeable people out there willing to help, that's super important.
yeah, no, yeah, we definitely didn't really have much of a community in Haskell. Well, I don't know why I'm saying we. I barely know much about Haskell. I know how to read Haskell. I've never really written a lot of Haskell until this project, so yeah, I wouldn't really say I'm part of like the Haskell community or anything like that. Most people probably know me more as being someone from the Rust community, but yeah, just it's been interesting learning stuff from Haskell and seeing how it grows and what people are using it for, that kind of thing. But yeah, it has its share of problems like space leaks and stuff like that. It can be, or I guess like space explosion problems. the laziness can kind of cause those issues. And I know other new FP languages like Idris have been trying to address that, but the newer FP languages are also trying to implement things like dependent types, and that's a whole different ball game because people are still asking like how practical are dependent types? How much more do we get out of them? Can we actually justify the use of dependent types in in enterprise software and stuff like that? And it's definitely very interesting. Definitely a lot of stuff going on in the FP world still these days, and
Yeah.
a lot.
When I think about FP, it seems like, okay, if you ask like a mathematician to invent programming, it's like totally that's what FP is. Whereas
Yeah, kinda.
OO is like you ask like I don't know some like very practical engineering type to come up with a programming language, and they're like, okay, here's what I got.
Yeah, that sounds pretty much correct. But FP has its we found its uses, and
Oh no, I'm sure it does. Like
especially in like
I've heard whisperings of like how it makes parallel programming much easier because if you don't have state, then you don't have to worry about like race conditions or crazy parallelization problems.
yeah, we might touch a little bit on, well, not parallelism specifically, but concurrency with this project.
Yes.
So there you will,
Yes.
or at least I think we definitely will because we're going to make this multiplayer. So you'll
Right.
see some of the interesting things that Haskell has to offer.
Cool.
But for now, we're still stuck on IOC because God, we have to reinvent the wheel. We have to start from scratch. We must create the universe first. So anyway, like I was saying, we create these EDSLs and then later we interpret them. Right? The interpreter is the actual implementation. And so here I actually played with a couple of interpretations. We have this interpret logger f, which just takes a logger f and returns IOA. And what that's just going to do is it's going to do a put string line. It's just going to print.
So this is like the implementation of the interface, right?
Yes.
So we've defined our data type, and now we want to actually do something with it, right?
Exactly. And you'll notice I'm actually throwing the log level away. That's purely because I'm lazy and I didn't want to actually.
Well, whatever.
check
It's
the
like
log
it's
level.
a proof of concept.
Yeah, I mean, if I had
gonna
like
log
a
something,
real,
sure.
if I had like a real logging library, it'd probably want like an actual log level, and I could do like the case of on the log level, and in each case we could print string line or not print string line, whatever the API is for that logger. We could use that instead. But this is just a proof of concept that this works. I can print strings with that. Interpret logger L is more boilerplate. So
Fold free, dear God.
yeah, we have to use this thing called fold free. I don't really know how it works, but you pass it the interpret logger F function, and it basically returns a new function that takes a logger L and produces an IOA. This is another thing that has to do with the free monad thing that we're using. So just a little bit more boilerplate. Don't worry about it too much. We'll be using fold free again later.
Don't worry, I've already forgotten everything I ever knew about fold free, which was nothing.
So yeah, that's pretty much it. You'll notice I have this like pure call here. That's because every line in this thing has to return IO or an IOA. If I just call next is not going to return an IO. It's going to return a unit, or well, I guess it's going to return whatever I think A is. So we need to wrap that up in pure, and then it'll just go. Yeah, in this case, it's going to return unit. That's right, because when we print, we don't return anything. I think there's a shortcut for it called return, or not a shortcut, but a more imperative looking syntax for it called return. I want to try that because I actually don't know if that works. Here's a mock version of the same thing. This time I don't do the put string line. I just return next unit, and that's it. And this is the same equivalent boilerplate for the mock interpreter.
Cool. Are we gonna like write unit tests for this bad boy?
We are, and guess what? This book
Ooh.
that I'm reading, that I've been basing everything off of, doesn't talk about unit tests at all. I don't know why, but it
Interesting.
doesn't. It hasn't mentioned how to unit test anything so far. So,
Hmm.
and I'm
That's not like a score for, that's not a point in functional programming as like something that you would use to write like software in a company. It's not a point in their favor. It's like, oh,
no.
unit test, like, whatever.
Well,
I'm sure it's fine.
there's still 90 pages left.
I'm tenured. I don't care.
I haven't read the last 90 pages of this book. It's a 344 page book, by the way.
Okay.
But
Yes. Well, then I'm sure it's lurking somewhere in
it
like the
might be there.
appendix.
It might be
Some
there.
software developers do something what is known as testing. You may want to look into this further.
Okay, well, I think they do intend for you to do testing. I just
Oh no, no, I'm just
yeah,
I'm just like joshing.
yeah, I think they probably just think, oh, it's so trivial that we don't have to really talk about it. But because I've never really done that before in Haskell, then I think it's gonna be a bit of an adventure. We're gonna be learning how to do some unit testing. And
Where do we inject our moss logger? I want to see.
well, yeah, we'll see how that works. Anyway, here's an example that I wrote. This is using our logger L. So here's a function called log some messages. It returns a logger L script, parameterized with this, or we pass in this unit, because obviously when we finish logging, we don't return anything. And all it does is it calls log message, passes in the log level of none, and it gives it the message hello, and then it does the same thing again, but with world. And now
It's ignoring the log message anyway, so not
yeah,
that it matters.
it's ignoring the log level anyway. So
Yeah.
if we pass that in to interpret logger L here in main, right? We can pass it the log some messages script. Then when we go back up here, we should be able to do a Cabal v2 run, and it should work.
Oh my gosh, so exciting. Uh-oh.
Oh, whoops. that's our C
Oh,
sharp.
that's because the example was left in there. Whoops.
Yeah, that C sharp stuff. Oh, actually,
Right.
I didn't save the file. That was dumb of me. Here we go.
Oh.
Let's run this. It might fail
Here,
to compile
wait,
again,
go.
but we'll see.
Here we go. Hello world.
Hello world.
Nice.
There we go.
We logged it so good.
We logged so good. Yes. So that's a basic example of how this works. We're going to be writing all our business logic in these little scripts, like so, and then we're just going to pass that script into some interpreter like this. And
Cool. All right, so we need like those two fundamental components. So we need the script, and we need the interpreter, and I guess we also
Yes.
need to define sort of the
language.
data types involved, the language, right?
yeah,
Okay,
we need
so
to
three
define the
components.
language. 3 components.
Right.
Exactly. That's exactly how this works.
Okay, so we've just written like the FP equivalent of like logger.java.
Yeah, we've created a logging facade.
Right.
And we could go even further, and we can define a language for our business logic, which is what langf is. I'm going to hold off on that for now. I think next... so my plan is to try and implement the languages, or like define all the languages at least, and then we'll do some unit testing, if I can figure out how to do that. So next, after logger f, I think we'll do network L. So this is the part where we have so much code everywhere that I'd start breaking things into separate modules, except this is Haskell and I don't really know how to do that. And this is probably a good time to learn how as well. But I just want to defer that until
Reminds me
later.
of the good old days of doing everything in main.
Yeah,
It's like,
basically.
I only need one class. It's fine.
Yeah, it's like, I don't remember how to do everything I'm supposed to. We'll do it later.
Yeah. Let's just quick add one of those weird Haskell comments with a to do, refactor this with no Jira. It's fine. We'll definitely do it later.
Sure, let's do that. Here, to do, refactor.
Refactor.
Yeah.
Perfect. The most useless comment that serves no other purpose other than making you feel a little bit better for committing kind of crappy code.
Yep.
Okay.
All right. So next is our network layer. This one's going to be kind of interesting, I think, because we have to define what instructions we want to do for networking. So
What
in
do we
our
want to do?
so we're doing rock paper scissors. We
Right.
want to be able to send messages to the client, right?
Yes.
Because what I'm assuming is we're gonna have like a couple of threads, one for each, one to serve each of the player clients,
Right.
and there's gonna have to be some synchronization between them, because obviously we have to compare the results and determine who was the winner, and then send that result back. But
Right. So you need like a send, and you're gonna need a receive. Whoops. That's
yeah,
for sure.
so
At a
we're
bare
gonna have
minimum.
some kind of like send message.
Yeah.
We're gonna
So
have
this is
something
like, yes, send it to the client. This will be sending the state of the game to the player, and then receive message. Okay, this guy has just said rock, so I better
yeah.
make a change to the game state.
Yep, exactly. So here's all our data types that we defined last time.
Right.
Oh, I actually defined like request and response types.
Fancy. All right. I suppose we'd also want to be able to connect and disconnect.
Yeah,
All
we
that sort of stuff.
probably want that too. So that's stuff that we're going to need. This is the game result. But we could try and make this generic, right? I think we could make this generic. Like if we want to send something else, we could send that instead. Yeah, like if we make it agnostic of the actual like inner workings of the game, that's probably better. So
Sure.
if we send a message, we aren't going to return anything, so this should be unit. I guess our message can just be of type A. we take an A, and then we'll send it, and that should be it, I think.
Oh, it's going to return a logger?
Oh, it's not going to return a logger.
Logger.
That's boil. See, this is what happens when you have too much boilerplate. Then you
That's just
forget
the
to
perils
copy
of
and
copy
paste it.
pasta.
Exactly, the perils of copy pasta. So it's gonna take an A. It should probably take a connection too, right? Or
Yes, that seems like it would be important.
except I don't know if I accounted for that, because I imagine we're gonna have to take the actual player connection. I don't know. Well, whatever. We'll leave it as it is for now.
Right. Question mark.
That's something
Connection.
that maybe
Going to need to have to be maintaining a connection or establishing a connection at some point.
Yeah, that might not have to be part of this logic. It could be something that we do in the interpreter, at the interpretation level, in the implementation. So we'll just leave it as is. This one shouldn't take anything. Instead, all it should return is the message that we receive from the user. Network F next. We want to derive functor as usual.
Hold on a sec. So we're receiving a message. We need to receive the message that the user sends us. We're thinking about this from the server's perspective, right?
Yeah, we're implementing the server. I forgot to recap, but yes, this whole thing is just for the server. We're not doing the
Right.
not touching
Okay.
the client yet.
So send message. We are going to send some message to the client. That makes sense. Receive message. Don't we need to receive some message from the client? Like, don't we need to have an input that's going to be the message that the client sent us?
That's A.
I
it's
thought this
not-
was boilerplate. This whole blah.next thing.
No, just this part is boilerplate. The part before the arrow is not. That's actually what's being returned. So in this case, when we send a message, we return unit because we don't want to return any value when we send a message. And when we
Right.
receive a message, we don't want to pass in anything. We just want to receive.
So A is the message that's coming from the client.
Yeah, A is the message that's coming from
Okay.
the client.
Okay, cool.
And at least I think that's what we want to do. This is just like a first draft. I have literally no
Sure.
clue if this is correct or not. This is based off of the approach in the book, but it's not actually copying anything from the book directly. So we're kind of winging it a bit here, and we'll learn
Okay.
from our mistakes as we go. That's part of the learning experience, and that way
Certainly.
we can have a better idea of how to compare this approach versus like Java and stuff like that. Like just how much more awful is this? So that's going to be our networking interface. I think we're going to do this again, this little constructor helper function to make this a little bit easier. We don't need a log level. All we need is a message, which will be of type A. Or we can just call it message. You know what I find funny? We always call our generic type arguments a single letter. In most
Yeah, I mean,
languages.
like, this isn't 1982, guys. Like, we have more than like 1 kilobyte of RAM. It's fine. We could be a bit more descriptive.
It's like, why do we do that? I don't understand why. Like, why does it have to be T or why does it have to be A instead of something a little bit more descriptive? I don't know. It's weird. That's what we're gonna take, some generic message, and this will be called, I guess, send message. This will be the definition. Take message, lift F, and this will just be send message. It takes one argument and the identity function for the continuation. And we'll just do the same thing again. This time for receive. This time we're not returning a message, or sorry, we're not passing in a message, we're just returning one. So should be fine to do that. Get rid of the argument. Then we'll just do this. And there we go. That's I think that's it. I think that should work.
Okay.
So that would take care of the network stuff. So next we have state. So this is going to take care of the actual game state, and I think we're going to have some kind of state for like passing passing between like threads and stuff like that. So based on what the book told me to do, I'm going to be using something called STM, and STM stands for Software Transactional Memory. And this is a very I guess I don't know if it's a functional technique, but it's a thing that Haskell uses a lot. In fact, we can look it up. So Software Transactional Memory, Haskell. They've got some pretty neat examples. One that I really liked was from this blog post here. Sorry if this like sudden amount of white is like burning your eyes.
That's fine.
But essentially, the way that it works is it's supposed to be like more composable than lock-based concurrency methods. So there's this like a TVAR thing. Here they're creating like a binary semaphore, also known as a mutex. And you can create the new semaphore by passing in a boolean to say whether it's available or not. And you call this new TVAR IO function. This is built in. It's what into this STM library. And P and V are, I think, for taking the lock and releasing the lock. So in P, we take the lock, or SEM.
We have acquired it. It is ours, and no other threads.
Yeah, we try to, well,
my rights.
we try to read it. We try to read the value from SEM. If it's true, so if the lock is available, then we'll write false to the lock.
Right,
that
we
way,
will take it.
Yeah, that's how we indicate
we've taken it from the library.
Or we're just going to retry. And retry is another function from the STM library here.
Huh. So it'll just like handle that for you automatically, just like with some sort of a like exponential backoff kind of deal. Maybe. I
don't know. Yeah, I think it uses exponential backoff by default. They mention it in the book that I'm reading, but I think you can configure it to use a different retry strategy. But I think the default might be exponential backoff. I can't remember. But yeah, this will just automatically take care of that for you. It's actually pretty nice.
So it'll just like continue to retry until it can acquire the lock, do its thing.
Yep,
and
that's
then release.
that's
Cool.
exactly what
Just
this
in
does.
like one retry. That's pretty sweet.
Yeah, this is really nice. That's what they're talking about here. Like the most impressive thing with transactional memory implementation in Haskell is, in my opinion, the retry combinator. So this is actually pretty neat.
Yeah, no, that is neat for sure.
And releasing is simply saying write true, so saying that it's available again, and that's pretty much it. And they use this implementation down here to implement the dining philosophers problem. So you've got this like atomically do, take fork 1, take fork 2 kind of thing, release fork 1, release fork 2. So it's pretty cool. And atomically is another function that's part of the library for STM. So that's software transactional memory in a nutshell. It's just this API that makes it super easy to do concurrency with mutable state or like shared mutable state. And
My takeaway is it's like some cool library that has this retry keyword that's super awesome. That's pretty much what I got.
yeah, that's I guess you could say that's all there is to it. It's supposed to be, well, as the name suggests, it's supposed to be transactional, right? And if you know what a database transaction is, you know that it has to.
So are we going to be able to use the retry thing in our program?
Yes, we will be able to use the retry thing in our program.
Exciting.
Yeah. So we want to be able to accommodate that, but in order to do that, we're going to have to implement some. We want to abstract this away first. Because that's what the book says to do. We don't want to be stuck to like the STM implementation in case we want to swap it out for something else. Don't know what you'd want to swap it out for because STM seems to be kind of amazing, but maybe if you have like a more performant thing that is a little bit less safe, a little less convenient, you could swap
if somebody comes up with the RIP STM library, then you want to swap it out for RIP STM.
Well, you could always just mutate a variable and hope like no one else accesses it at the same time without like the lock and stuff. Like you could do bad things, right? And that's gonna be faster, but it's also a lot less safe. And but in certain scenarios, it might actually be safe to do it, right? It just depends on what you're trying to do. So STM is like this is the safest option. It'll work. It might be a bit slower because it has to do all this like retrying and do atomic access stuff, etc. But it's probably a lot safer than say just doing it in IOF.
Sounds good to me. To like frame this in a language that I am more familiar with. So if we wanted to make something sort of swap outable, maybe you'd implement an interface or something like that, and you'd have some generic sounding methods, and then you could have multiple different implementations of that interface and swap them out as you needed to. So that's sort of like the starting point. And now we're going to find out how to do that in FP land.
That's what we've been doing the whole time.
What? Oh, okay, right. Oh yeah, we have send message, receive message, right? Okay.
Yeah.
Okay. Never mind. I was turned around for a second. Okay, sounds good.
So we're gonna create a state F, and this is gonna take care of using STM stuff for us. So, oops, I don't know why I copied that. We're gonna have something like new var, and that's gonna be used to create a new T var or TM var, whatever. I don't know exactly what I should be using at this point right now, but I don't really care. And what is this doing? We'll just say next there, and I don't know. We're gonna need to do something like this probably. I don't know if new var needs to return something. That's something I'm not actually sure about. We might actually need to return the actual variable itself that we're defining. So maybe this should be an A. I actually don't know. Doesn't really matter. And we're gonna want to be able to like, I guess, get from that variable. So we'll pass in.
Would you say new var? Like the var here is just the state of the game.
Yeah, it's a state thing, kind of like this new tvar thing here that they're calling,
okay,
right?
okay.
So they're calling it directly because they're working. They're not trying to abstract anything out. They're not trying to make sure the code is more flexible. We're trying to be engineers, right? We're trying to
Right.
hide stuff behind abstraction so that in case the implementation changes or we want to like mock things and test them, we can do that. With STM, we want to be able to actually like mock this so that we can write unit tests for it later. So that's why we're defining this state F
Right.
interface.
So we want our interface, and one implementation is going to be the STM implementation. But
Yes.
we're going to have a mock implementation, and maybe we want to swap the STM implementation out one day. And so let's do that.
Yeah. But mostly we just want to do this for unit testing. So we're going to have like a read var. It's going to take...
Like, we're never going to swap out the implementation, but, you know, maybe somebody will. But yeah, definitely the mock stuff. Is there no like sweet unit testing libraries in Haskell where you can kind of get this for free by just like creating mocks using that library, like Mockito style?
Probably not. Well, there might be some for certain styles of abstractions in Haskell, but like the problem is like we have multiple different ways of abstracting things out. For example, if I wanted to, I could do things. I could do this in a more object-oriented way. We could define something like, I don't know, a record almost. How would you define this in a record? I don't know. Let's use like a database, for example. Like we could have like a database record, and it could have I don't know, a connect method. It could have like a send SQL method. It could have like a delete. Yeah, we could actually. Yeah, we could do like select, delete, whatever.
This is looking more interfacey. I mean, in a syntax that I'm more familiar with.
Yeah.
Like these are.
What you could do is you could take functions instead. Like so, you could store a function for each of your record values or record fields. Sorry, and that's how you could sort of do this in a more object-oriented way if you wanted to. So when you construct a new database, for example, then you would pass in a function for how you want to do the select implementation. And if you want to do like if you wanted to create like a mock, sorry, now I'm breaking character. I'm just writing out like C# or whatever. But if you wanted to do like a mock DB versus like the real DB, you could pass in like real, or like this one's the mock method, mock select method, and this one would be like the real select method, right? So you'd do it on construction instead, and that's a different way of achieving what you'd do with like an interface, but on the instance creation level instead. So you can do that instead in Haskell, and that would also work if you wanted to do IOC.
Okay.
So to your point about creating mocks, it entirely depends on what method you're using to create your mocks. And so creating a general mocking library just doesn't work, because there's a lot of different ways you could do like IOC. You could do this. You could do you could do this EDSL. That's kind of part of the problem of having so much choice. Like you just can't really write general solutions like that. Whereas in like object-oriented programming, there's only one way of doing everything. So you can
that actually kind of suck, because unit tests and like testing, there is a lot of boilerplatey stuff associated with it, and so it's really nice to not have to explicitly like abstract things out into an interface and like have a mock implementation. It's nice to just be able to say like, hey mocking library, make me a mock of this, and when I call this, return this. Thank you, goodbye.
Well, you could certainly still do that in Haskell with like macros. If you're using like template Haskell, you could do something like that. But yeah, it depends entirely on like what kind of what kind of IOC you're using. Like in Java, you still have to use interfaces to mock certain things out. I mean, yeah, you could mock like a struct or like a regular like plain old Java object too, but it's a bit different. Like if you
Well,
want
I
to be
mean,
able to
like,
swap different implementations, right? Generally, you're going to be doing it with an interface, even if you are using a mocking library. You can't you can't just like mock the implementation of your database, for example. You have to set up like some kind of interface for that.
yeah, sure. I guess for something more complex, but you know, if you're making some change to like, uh, I don't know. I mean, like most of the unit testing I do is not on that level, right? Like you're modifying an existing code base. Somebody has already figured out you know, how to mock these giant components, and you're adding whatever class, and it's going to have these dependencies, and you just want to mock out the dependencies so you can test the class in isolation. Like I found, like we use easy mock, and it's pretty handy. Like it's very simple to just um, like mock out the dependencies without having to worry about implementing any kind of an interface or anything like that.
Yeah, that's. I mean, I guess so. But what if you call one of the interface methods? Then you still have to define like some like mock implementation for that, right?
Well, I don't know, maybe we're not talking about the same thing, but like what I'm thinking is, you know, if you have class A and class A depends on class B
No,
and class B has,
like I don't know. I'm talking more like if you have like a database, right? You let's say that you create a mock database like this. This is from like Scala, um,
sure.
and then you call like database dot like I don't know delete row, for example. You don't know what delete row is going to what delete row is going to do though, right? Because it's just a mock. So you have to define some kind of behavior for it. So what you're
Right, yeah.
probably going to do is something like I don't know db.delete row, and then you'd like define like like accepts I don't know some argument here and returns
Oh yeah, 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 for sure. Like you have to
whatever.
say, you know, when,
Yeah, you still have to do that kind
you
of
know,
thing.
when I call my dependency with blah, I want it to return blah. Yeah, totally, you still have to do that. But I just mean like, it sounds like what we're talking about here for this example is that, you know, we have these, uh, I'll call them interfaces because I'm still very like shaky on the FP terminology.
Oh, I mean,
And
it's
we're going
it's
to have an
basically just like a
actual,
functional interface, right? Like interface, like the general terminology is just like what kind of like what you're thinking of, right? It's just something where you can like plug in different implementations into it.
okay, so then like my question is in Haskell, how easy is it to do this kind of like dot accepts, dot returns, blah, versus having a full blown, you know, mock implementation of whatever you're testing, like whatever dependency you want to inject.
I have no idea. I have literally no idea. Let's see what does Reddit say. Mocking libraries, yeah. Mockito, I've used that.
Oh, there's Mockito for Haskell? Or is he saying he wants something like
No, he's
Mockito?
saying in the OO world, this is typically done.
Oh, yeah,
Their
yeah, right.
mocking libraries like Mockito go away. What do people have to say? It's generally good practice to avoid writing database code directly in I/O if possible. Yeah, see, this is a different way of abstracting stuff out too. So that's not using the EDSLs that we're using, as far as I can tell.
Hey Google, turn off the living room.
Anyway,
Yeah, I don't know.
I
I don't know if there's
railed.
anything for this. Doesn't
I
seem
just
like.
was like, I think I was misunderstanding what you were saying, but I think we're on the same page now. There's probably some way to do this in Haskell, but that's another can of worms that can be
Yeah,
opened at a later.
there's a can of worms that maybe we'll dive into a little bit later.
Sure. And I also have to give my like 10-minute warning here. I got to get up pretty early tomorrow, so I'm going to be calling it a night fairly quickly.
Okay, sure, sounds good. Um, I guess we can leave it there soon. Then I guess. Let me just delete this and
Sure. Yeah, so where did we get to? We were just doing the STM stuff. We were talking about how we were going to handle concurrency, thread safety, and
Yeah,
one
we
and then one thing I was like kind of conflating is like this whole game state where we're going to need to just maintain a state, of, who's played and who won the last game and all that sort of stuff. When you say state, like that's what I think of. But this state is more related to concurrency because we're dealing with STM here.
Yeah, we're probably so the way that the book does it, they also pass in they pass around like a state runtime, which basically is it's almost like a context that has all the state in it. I don't want to say singleton, but I guess it's similar to that in a way. But yeah, it has like all the state of the application in it, and
Right. And so like just thinking this through, so we're playing a round of rock, paper, scissors, and we have the game state. Player one has made their choice. Player two has not yet made their choice.
that's what this is
So,
for. That's what
right,
this is
that's
for.
what this is for because we need to we do like read var, and then that would tell us that we're still waiting for one player to make their choice.
Yeah, and then we'd retry
Right.
or whatever until timeout is hit or whatever. Yeah. So
Until like the
that's
current timer expires or something.
exactly.
Right. Okay. Okay.
So I was in the middle of I think reading from the variable. So I think we take a variable, and then we return the value from the variable, and then we return next. I'm guessing at this point. I have literally no clue if this is going to work. We'll find out. We'll find out the hard way.
All right.
Same here. We're gonna take a variable and we're gonna write a value to it. I think. No wait, no. If we're writing, we don't return anything, so we do this. And that's pretty much all there is to this, I think. We might need like a retry thing here too, but I'll leave it at that for now.
Sure. Okay, cool. Yeah, we're making slow but steady progress here. I know I'm slowing things down by asking a ton of questions. I hope that's okay.
Yeah, no,
But
that's fine. I mean, the whole point is, learning, teaching. I mean, if you're having these questions, I'm sure like other people would have these exact same questions too. Like, if you're not used to functional programming, it's just not something that that sticks with you.
yeah, it's totally like a different way to look at the world, especially when you're just you're used to looking at things in one way.
Yeah,
Hard
if
to
if
kind
you've
of
been
wrap your
doing this
mind
for
around
like the
another way.
last 5 years of your life or something, like sure, you probably would say, "Oh, this is all old hat. It's not really that hard. I can just kind of breeze through this." But if you're relatively new to this, then it's a lot to take in and it's a lot to try and keep in your head. So
Yes, and especially when like your FP lessons are like mine are pretty much exclusively with you, and they're spaced at like a couple months apart, just long enough for me to forget everything.
I'm trying to do them a little bit more frequently. It's just I need to stop taking on so many like other things that I'm doing in my life. Like we're working on a game jam and
Oh yeah, yeah. Hey,
preparing
no rush. Like
for
no, I will be
meetups and
here. You
stuff.
do your game jam stuff, you do your meetup stuff, and yes, we will reconvene when you have a bit more time.
Mm-hmm. Actually, I've been thinking
Cool.
of uploading some videos to my channel too, like a channel introduction and stuff. Stuff to make the channel feel a little bit more like legit.
Yeah, sure. Yeah, sounds good.
Maybe get some more educational content through videos instead with some pretty animations because I think that
Ooh.
the animations
Involving a
stick a
fan,
lot
hopefully.
better. Like you know those like on Wikipedia how they have like quick sort and merge sort, and they have like
Oh yeah,
those
yeah. Like the
animations.
little gifts that
Yeah,
are
yeah,
just
yeah.
like showing in action. Yeah.
Like that stuff sticks with you, right?
Yes, yeah, for sure. It's helpful.
Yeah, I want to do similar things, but for like functional programming. Like how does the do notation de-sugar and like how does that work? Like that kind of stuff can like
Yeah.
really stick with
Well,
people.
yeah, having just like different explanations for people that prefer, visual versus, just listening to you talk versus whatever, right? It's nice to just hit on different have multiple approaches to sort of explaining this stuff because it is tricky for sure.
Yeah. Well, anyway, if you want, I guess we can leave it at this, and we'll continue next time, and maybe we'll try and do some
Yeah.
unit testing next time too.
Sounds good. Thanks for the knowledge. It was cool hanging out, and I'll talk to you next time.
All right. Talk to you later.
Okay, see ya.
Bye. And now I'm going to end